do some trickier exponential models. And again, for some reason we love talking about bacteria when we're doing exponential models. So today will be no different. Let's say we have 40 bacteria. Let's let x equal the number of hours and let's let b equal the number of bacteria. So we're just going to do a few examples here. Let's say that the number of bacteria doubles every third hour. Number of bacteria doubles every third hour. Let's try to come up with an equation for that. Think about it. Pause the video. For each one of these, pause the video, see if you can come up with a model, and then see how you did. Okay, here we go. So my number of bacteria, I'm starting with 40. I'm doubling the number of bacteria, so that means I'm multiplying times 2, times 2, times 2, times 2. But I'm not doing it every hour. I'm doing it every third hour. So my exponent is going to be a fraction. X divided by 3. And we can always think about plugging in numbers if we want. So my number of bacteria is going to be 80. It's going to double after 3 hours. It's going to double again after 6 hours, after 9 hours. That kind of makes sense. So every third hour, so you're going to divide your number of hours by 3. All right, let's try a different scenario. Let's say the number of bacteria doubles 4 times an hour. 4 times an hour. Okay, so again, I'm starting with 40 bacteria. It's doubling, so my number there is 2. I'm doubling, multiplying by 2. And I'm not doubling just every hour, but 4 times per hour. So now I'm doubling a whole bunch of times each hour, 4 times an hour, as opposed to every third hour. You see the difference there? Let's look at a third example. Okay, so now the number of bacteria are going to halve every 6 hours. Halve. So I'm going to have half the bacteria I had before. Again, I'm starting with 40 bacteria. I'm halving, so I'm going to multiply by 1/2 or 0.5, whichever you prefer. But I'm not halving every hour, but every 6th hour. Every 6th hour. I like putting a TH. Every 6th hour. And that reminds me, it's a fraction. Okay. Let's do another example. Let's say that my number of bacteria grow by 15% every 2 hours. My number of bacteria grow by 15% every 2 hours. All right, well, I know I'm going to start with my 40. It's growing, the number is growing by 15%. Well, that means I have 100%, which is my 1, plus 15%, which is in decimal land 0.15. So 40 times 115% is really what I'm doing, but I'm writing 115% in decimal land. Every 2 hours, that means every second hour. So that exponent will be x divided by 2. Now some of you might be saying, well wait, couldn't I have written this like this? B equals 40 times 1 plus 0.15 to the x over 2? And the answer is yes, of course you can. When we have a percent growth, remember we often think of the 1, which represents the 100%, plus 0.15, which is your percent increase. You could leave it like this if you wanted, or you could write it like that. Let's look at one last example. Let's say the number of bacteria decrease by 6%, 10 times an hour. All right, so here we go. I'm still starting with my 40 bacteria. I'm decreasing by 6%. Okay, so again, if I'm starting at 100%, but I'm losing 6%, that means I'm left with 94%, which in decimal land is 0.94. But I'm not doing that every hour, I'm doing it 10 times per hour. Sneaky. And as with the percent growth, some of you might instead like writing this in a slightly different way. 40 bacteria. Remember, with the percent decay, you can think of you're starting with 100% or 1, and you're subtracting your 6%, which in decimal land is 0.06, and you're doing that 10 times per year. So you could, instead of writing it like this, you could have written it like this. That would be fine. You can even leave it like that if you want. But of course, if you do 1 minus 0.06, you're going to get 0.94. Okay. Well, there are 5 examples of some tricky exponential models. I hope this helped.